So now I want to talk about A.6. That was a good overview of A.3. Now I want to move over to A.6. In A.6, we talk about inequalities and absolute value inequalities, something that is imperative for your study of pre-calculus because you will use them and the idea of them in calculus. And so we want to get a good foundation for that information now. So I have an example of an inequality here on the board, and I want to talk about how to solve this, what its graph looks like, and then we'll move into absolute value inequalities. Because this is a particular example that I want to do, and we'll talk about it when I get there. So when I'm solving this, I personally like to have my x's on the left-hand side. It does not matter, it is just by convention that we typically move x to the left. So I'm going to start by getting rid of the 4 on the left-hand side and moving it to the right. To do that, I add 4 to both sides. Okay? And so that leaves me with 6x is less than or equal to 6 plus 8x. I still got this 8x over here, so I'm going to move it over to the left by subtracting it from both sides. And so what I have over here is 6 minus 8, which is negative 2x, is less than or equal to 6. So this is just like we would solve an equals, except I'm moving, I don't have an equal symbol, I have a less than or equal to symbol. Now here's the part where we've got to be careful, and I'm going to put a warning symbol right here so that we know, hey, something's about to happen that's unusual. And this is what it is. I'm going to divide by negative 2. That's not the unusual part. We would normally do that when solving equals problems so that I get this cancellation of x. But when I divide by a negative, I have to switch the sign. Literally, instead of being less than, I make it greater than or equal to, and then the division goes as the same, so that's negative 3. So I'm going to put that note right here. So when you divide by a negative in an inequality, switch the sign. That is exactly what I did right here. To go from this step to this step, the sign gets switched. So that's very important. So if I look at the graph of this, on my x number line, then I've got 0 at negative 3, it is equal to it. So there's two conventions that I can use. I can either draw in a solid circle because it is equal to, and then shade everything to the right. So all of this to the right of negative 3 is my answer. Additionally, we usually write this in interval notation. So in interval notation, we write the answer to be equal to negative 3. In interval notation, equals is a bracket up to infinity. So here's the graph, and here is the interval notation. 9 times out of 10, this will be the notation that you are asked for in 171. It is much more condensed and convention to use interval notation. So here we have an absolute value inequality. So we have the absolute value with an inequality. This says something very important, and if we really want to get that into our minds about what this is saying. So this sentence says, the distance around 8 is less than 3. Okay? So this says that the distance from 8 is less than 3. Now what does that look like as a graph? So the from 8 part says that we are centered around the value of 8 with a distance of 3. So 1, 2, 3, that's 8, 9, 10, 11. And then 3 down, 8, 7, 6, 5. So 5 and 11 are the ones that are exactly 3 units around 8. But this says as long as my distance is less than 3. So I could potentially be all of the stuff inside of here. The question is, can I be 5 and can I be 11? And the answer is no, because this is strictly less than, which means that my distance cannot be 3, which means I cannot be the endpoints. So one way we could signify that is these open circles at those particular endpoints, but we can include everything else. And again, we want to use interval notation to discuss this. So this is all the points from 5 to 11, and we use the parentheses to say that we don't include 5 and we don't include 11. So what if I wanted to solve this problem again, except using the algebra? Because some problems I can't always manipulate and use the thought, the idea of the graph. I actually do need some algebra tools in order to do that. So what I can do is break this down into 2 separate problems. The first one is, well, the absolute value, it could just spit out the number itself. So if these values are positive, then this thing goes unchanged, right? Because the absolute value of like 2 is just 2, or the absolute value of 3 is just 3. It doesn't change the actual equation, or in this case, inequality. So one possibility is that these values were all positive, so I had just x minus 8 is less than 3. And this could be one of the possibilities. The other possibility is that the values inside of here in my absolute value were negative. Well, if they were negative, then they would look like negative x minus 8 is less than 3. But what happens here is that if I go through this process, let's say I divide the negative through, if I divide both sides by negative 1, then remember, dividing by a negative flips the sign, so I have x minus 8 is greater than negative 3, and then add 8, I get x is greater than 5. Doing the same thing over here, adding 8, I get x is less than 11. So let's think about what this is saying. This says x is greater than 5, but x is less than 11. So on the graph, we're at 5, and we're at 11. We have to be bigger than 5, but less than 11. That's all the stuff inside of here, which is what we had last time, but I'm not including 5, and I'm not including 11. So I have 5, 11 again as my interval notation. Same problem, same concept. The distance around 8 is less than 3, but this allows me to solve problems that maybe aren't written in this fashion. And let's do an example of that. Now notice in here, it's the x value is not by itself, so it's hard to see what I'm centered around. And moreover, this is positive and this is negative, which is not like the previous example. But with the skills from the last problem, I can solve this. So if I break this down into its 2 possibilities, the one where we first don't change anything, and just call this 7 minus 2x is greater than or equal to 5, or this is the negative version of this, then I have 2 inequalities that I can solve fairly easily using my algebra skills. Let's just start over here and move that way. So again, divide by the negative, you're left with 7 minus 2x. Switch your signs. Okay? And you could stop here and think about this. What pattern do you see between these 2 things and the original? So you'll always have 2 inequalities to solve in an absolute value inequality. The question is, what do you notice about this part of the equation and you could skip this step each time. But I persist, so we would subtract 7. So we would have negative 2x is less than or equal to, let's see, 7, 8, 9, 10, 11, 12. And then divide by negative 2. So I get x is greater than or equal to 6. Notice I switched my signs. And then over here, I'm going to subtract 7. Get negative 2x is greater than or equal to negative 2. Divide by negative 2. So I get x is, switch my signs, less than or equal to 1. Now I have to stop because this says something a little different than the previous one. Okay? This says that x is bigger than 6, but less than 1. So if I draw that on the line, the number line, we've got at 1 and we've got at 6. So x is bigger than 6, and it includes 6. So I can draw a closed circle and then shade everything that way. And then x is less than 1, but includes 1, and shade everything to the left of 1. Now you'll notice I have 2 intervals on the number line. I'm going to need 2 interval notations, or 2 intervals in interval notation, in order to actually do this. So the way we write this is we say this goes from negative infinity up to 1, including 1, so it's a square bracket, and then from 6 up to infinity, including 6, so it's a square bracket, and then to conjoin 2 intervals together, we use the union symbol, which is just a giant U. So this would be my interval notation answer for this absolute value inequality. And just to go ahead and tell you, all greater than or equal to absolute value inequalities will have 2 intervals. All less than or equal to absolute value inequalities will have 1 interval. And that's just how it works. Because this is pushing your interval away because you want your distance to be greater than 5, as where when it's less, you want your distance to be less than, say, for example, in the previous one, less than 3, so you're centered around a particular value. All right, so say we were given a graph, and it asked us to write the absolute value inequality for the given graph. So we actually need to reverse engineer the solutions and actually provide an absolute value inequality that would have these solutions. So this is where it's a great idea to think about what is the center of the interval and how far from each side are we from that center. So in this case, if we look, it looks like we're centered at about 2. In fact, this is 1, 2, 3 units to the right, 1, 2, 3 units to the left. So we are centered at 2, and our distance from 2 is 3. So we know we're using absolute value inequalities. For one, it tells us use the absolute value inequality, right? But also this fact that we've got this closed interval, this distance around a center really brings that home as well. So when we write this, we're going to have the absolute value of something is less than, in this case it's going to be equal to, because I can be the endpoints, and then this is going to be my distance. So my center is around 2. And this is where it's a little odd, because I'm going to have x, but it's going to be minus 2. We'll talk, this will come up again when we talk about transformations, but you're kind of shifting all the x values to the right so that your frame of reference now is around 2, not negative 2. So don't be fooled there. This is actually saying the distance from 2, not the distance from negative 2. Well, what is the distance? Well, it goes out only as far as 3 units to the left and to the right, and we want distance to always be positive, so this is saying the distance centered around 2 is less than or equal to 3. So this is the absolute value inequality that would have this graph. Okay? And that is how you would do a problem where if you're given the graph to actually write the absolute value inequality. So common mistakes, and the first one is this. We'll go back to A3 where we're talking about multiplying polynomials. So if you have something that's like x plus 3 quantity squared, what I don't want you to do is to say, well, that's the same thing as x squared plus 9. Because it absolutely is not. This is wrong. Okay, so don't say that these are equal. They aren't. All right. In fact, if you wanted to solve this, so the correct way you would say x plus 3 squared equals x plus 3 times x plus 3, and then you would either FOIL this out or box this out, however, whichever method you prefer, and that would give you x squared plus 6x plus 9. Notice these are not the same. You're missing that center or that 6x term. Okay, so don't make this mistake. Another mistake I see, and this is from A6, is when you say the absolute value of an expression like x minus 4, people want to say that just, you always change minus to positive, and that is absolutely not correct. Remember, the absolute value is the distance from whatever you're talking about. So in this case, you're really talking about the distance from 4, and that is not the same thing as just x plus 4. Okay, so this is a big don't make mistake because you will get the answer wrong 99.99% of the time. Another thing about this is, notice in the absolute value inequalities, like if you had x minus 4 is less than 2, then this says something totally different than just x plus 4 is less than 2. Like there's no true connection between this logic or this inequality and becoming this, because we said that if you're going to set them up, that should actually be a minus to make it correct. And then the other one would be x minus 4 is greater than negative 2. So don't make this mistake and think that the absolute value just makes everything positive, because it absolutely does not. And the third thing is really something that students forget, and that is, do not forget to change the sign when you divide by a negative in an inequality, be it a regular inequality, a compound inequality, or an absolute value inequality. If you have a negative and you divide by it or multiply by it, same operation really, then you must flip the sign or change the sign so that if it's less than, it becomes greater than. If it's greater than or equal to, it becomes less than or equal to. Okay? Because that will then mess up the rest of the problem if you forget to change the sign, and your solution will not be the correct solution.
So I hope that was helpful. Don't forget, if you have any questions, please feel free to reach out to me at esmith845@cvcc.edu.